Okay, so in this video, we're going to go over the following example where we're going to find the area of the region that lies inside the curve r equals 3 sine theta, but outside of the curve r equals 1 plus sine theta. Okay, so I drew these two curves, and these should be more or less familiar curves to you. The white curve is r equals 3 sine theta, so it has diameter 3, and it's pointed up. And the inside curve, the smaller curve in yellow, is r equals 1 plus sine theta, and that's a cardioid. Okay, so the first thing we need to do is we need to figure out at what angles we need to figure out these points of intersection. Okay, so we need to figure out where that intersects and where that intersects. Okay, so to do that, we're going to do exactly what we've done before. We're going to let 3 sine theta be equal to 1 plus sine theta. Okay, and when we do that, that says that 2 sine theta has to be 1, which is saying sine theta has to be 1/2. Okay, so we need to think about for what angles is sine theta equal to 1/2. So sine theta is equal to 1/2 when theta equals pi over 6 and when theta equals 5 pi over 6. Okay, so that should be this angle right here should be theta equals pi over 6, and over here this should be theta equals 5 pi over 6. Okay, so what we're going to do to find the area, this blue area here that I've marked off, is it's going to look very similar to what we did when we did disk washer method. Okay, so what we're going to do is we're going to find the area enclosed by the white the white curve, and then we're going to subtract off the area enclosed by the yellow curve. Okay, so our area is then the integral from pi over 6 to 5 pi over 6 of 1/2. Take our inner curve, our outer curve, sorry. Our outer curve is 3 sine theta squared d theta, and we're going to subtract off the inner area. So pi over 6 to 5 pi over 6 of 1/2. Then we take 1 plus sine theta squared d theta. Okay, so hint, when you're working on these problems in general, you really do want to set these up as two separate integrals because the bounds may not actually be the same. Okay, and to see why the bounds may not be the same, we'll do another example a little bit later on. Okay, so let's keep working on this. We can factor out the 1/2, and everything does have the same bounds, so we can combine the integrals. So let's combine them, and then we can FOIL everything. So we're integrating from pi over 6 to 5 pi over 6. We factored out the 1/2. So we get 3 sine theta squared is 9 sine squared theta minus, we're going to FOIL this. Foiling this, we should get 1 plus 2 sine theta plus sine squared theta d theta. Okay, so when we do this, we can actually combine the sine squared thetas. 1/2 pi over 6, 5 pi over 6, and then we have an 8 sine squared theta minus 2 sine theta minus 1 d theta. And now we can solve this. Okay, so this should be 1/2. We wouldn't take the antiderivative of this right away. We need to use another half angle identity. The half angle identity we want to use is, right over here, sine squared x is equal to 1 minus cosine 2x over 2. Okay, so, but this is over 2, so this is going to be 4 minus cosine 2 theta minus 4 cosine 2 theta minus 2 sine theta minus 1. We can combine the 4 and the 1. We should get 1/2 1/2 pi over 6, 5 pi over 6 of 3 minus 4 cosine 2 theta minus 2 sine theta d theta. Okay, now this is a basic antiderivative that we can take. So this is going to be 1/2 of 3 theta minus, should be 2 sine 2 theta plus 2 cosine theta evaluated at our endpoints, pi over 6 and 5 pi over 6. Okay, and now we're just going to plug in our endpoints. When we plug in our endpoints, we're going to get 3 times 5 pi over 6 that's fine. Minus 2 times sine 2 theta, but that would be 10 pi over 6, or 5 pi over 3. Plus 2 cosine 5 pi over 6 minus, plugging in pi over 6, 3 times pi over 6 minus 2 times pi over sine pi over 3 plus cosine pi over 6. Can we can then plug these in. So this should be 1/2. This is going to be 15 pi over 6. Now we can simplify this. That's pi over 2 minus pi over 2 should be 2 pi. There we go. Minus 2 sine 5 pi over 3 sine 5 pi over 3 should be root 3 over 2. So that'll be minus becomes plus root 3 plus cosine 5 pi over 6 should be minus root 3 times 2. So that's looking very simple. Minus, we already took care of this term. Minus becomes plus, because we're taking minus times this, becomes plus. Sine pi over 3 should be root 3 over 2 times 2 should be root 3 plus becomes minus root 3. And there's a 2 there. Okay, so simplifying this out a little bit, root 3 cancels with negative root 3, root 3 cancels with negative root 3. That looks very simple, and the area enclosed is actually just going to be pi. Okay, we'll come back with another example. Thank you.